Thank you for coming to our session this morning. It's ArcGIS Runtime building cross-platform apps. So the theme of the conference this year is all about how GIS is helping to enable the digital transformation of society and how it's inspiring that continued transformation as we go forwards. And in this session, I'm joined by my two colleagues here. We're here to help you understand as GIS developers, GIS implementers, GIS managers, perhaps, really how to help you understand how to use the tools and techniques available to you to build cross-platform apps to put GIS into the hands of more users and therefore help continue that digital transformation as we go forwards. And it's all about using the ArcGIS Runtime SDKs to do that. So the agenda for the session today then. Actually, sorry, before I start, I'll just introduce us. My name is Mike Branscombe. I'm the lead product engineer for the .NET SDK, the ArcGIS Runtime SDK for .NET. I'm joined on stage here by Michael Timms. He's the lead developer for the ArcGIS Runtime SDK for Qt, and also by Tyler Sheevey, who is one of the product engineers on the ArcGIS Runtime SDK for Java. So you get a sense of the topics that we'll be talking about as we go through. So the agenda then for the session this morning is we'll take a look at a review of the cross-platform considerations that you need to make when approaching the development. And that really helps set the context for many of the discussions and things that we'll be talking about as we go through the session. And then we'll take a look at each of the ArcGIS Runtime options in turn that give us cross-platform capabilities for application development. So we've got three options: Java, Qt, and .NET, hence our representation on stage today. So when talking about building applications without even thinking about necessarily cross-platform, there's often two broad strategies, and that is native applications versus web applications. And there's often a heated debate about which one of those is better. So let's take a look at each of those in turn then. So native applications, it's an application installed and running locally on the device, whichever device you have, maybe whether that's a Windows tablet or even desktop PCs we talk about as devices these days. That application is built from and has the ability to use the platform and operating system APIs. So the developer kits that are provided by platforms such as Microsoft with Windows or .NET, or it might be the Android SDK or the iOS SDK running on Android or Apple. Typically, these native applications are using those, calling right into those platform and operating system APIs. And what we find is that gives you typically the best performance of your application, and also provides the best device integration, so integration with the capabilities of the device and with the underlying platform APIs that the device provides. Native applications tend to provide the best support for both connected and also offline workflows as well. So those applications that are installed onto the device are able to run in a disconnected fashion. Obviously, the application needs to have been built to handle that workflow, but it's one of the capabilities of building native applications. And they work very well when you have the ability to determine the range of devices. So obviously, you can put an application into one of the app stores. They're available and make it available to a broad range of people. But when you're building a native application and you want to provide a really good experience for your users, and you're in more of an enterprise scenario, if you think that you're deploying to 500 known users of your organization, then you might be in a position to actually determine that they all have an iPhone 8 device, and then you know exactly what operating system version as well that they might be running, and you get the ability to tailor the application perhaps to the specific workflow and the experience that you want on that device. So for building native applications then, we have the ArcGIS Runtime SDKs, and that's what we'll be talking about today as we go through the session. Let's briefly consider or contrast that with web applications then. So web applications running on a device, typically it's a website or a web application that's been downloaded from a server onto the device, whether that's running within the browser on the device or it might be running within a framework that's actually installed on the on the device, but the content is downloaded from a server when you connect. And they work very well in scenarios where you want to support a broad range of users and you don't necessarily know the device types. So if you want the broadest reach of your application, and your users are typically going to be in connected scenarios where they have an internet connection, then a web application might be the best approach. When you have a more specific set of devices, operating systems that you're targeting, and you know that there might be a case for working offline, then a native application is going to work much better in that scenario. So for building web applications then, we have the ArcGIS API for JavaScript. And those are really the two development options that we recommend, either the ArcGIS Runtime SDKs for native applications or the ArcGIS API for JavaScript for building web applications. I will say this is kind of a view of the state as it is at the moment, state of technology. So the bullet point at the bottom of the slide there, so what we find is the user experience and the capabilities are actually increasingly blurred as these technologies evolve. So there are advances such as progressive web apps that are downloaded and installed onto the device, and they run full screen on the device, and they're able to cache content and persist that between sessions. So that starts to get towards providing more of a native application experience. And then there are advances such as the WebAssembly, which offers the ability to actually compile that code that's running within the web application, and that starts to approach the performance of native applications as well. So the experience is becoming blurred, but ultimately native applications have the ability to call into those platform-specific APIs. Maybe that's ARKit for augmented reality on iOS, something like that. So you get to the consideration at that point about what capabilities do you really want to provide into the application, what APIs do you need to use. And that's a trend that will continue, I think. Those experiences will continue to get blurred over time, and it's unknown about where we'll ultimately end up. So that's a consideration of native versus web applications. We'll assume that you want to build a native application. Let's take a look at the cross-platform considerations that you need to make them when you're approaching your development. One of the primary benefits of building a cross-platform application is the ability to share your application code and then run that on multiple different platforms. One of the things about sharing code across multiple platforms and architecting your projects and your solutions in order to do that is it tends to enforce good design patterns, and there's a number of different design patterns out there. For example, MVVM or Model View Model for .NET and other platforms as well, increasingly these days. And that enforces the separation of your UI from your business logic, and that has advantages for first of all your development, but also the testability and maintainability of that code as you go forwards. Obviously everyone would follow good architectural principles regardless of whether they were developing a cross-platform application, I'm sure. And also developing a cross-platform application allows you to do your development and then make that application available to more users. So it opens up the options of supporting more platforms. But there are also challenges to consider. So testing is one major challenge. So when you're approaching cross-platform development, particularly if that involves platforms that are mobile platforms, Android, iOS, Windows even, then you have to think about the testing that you plan to do for supporting the workflow in your application. Just because the cross-platform technology that you've picked allows you to support another platform, it doesn't mean you necessarily should. You need to think very carefully before just adding another platform to your development, because it means you have to support the application on that platform and support your users on that platform too. The user experience of your application may vary as well. So the different platforms have different capabilities. So it might be that you're constrained in some way on supporting all of those platforms, and therefore the user experience of your application may vary. Or there are perhaps technologies that allow you to support providing exactly the same user experience and the user interface on each device, but it's not necessarily tailored to a specific device. So those are considerations there too. When you're doing cross-platform development, you will have to handle platform idiosyncrasies. There are different security workflows and technologies and implementations, and even the web stack, the HTTP stack, is often different on those devices as well, and you may run into platform differences there, and you need to handle those in your code, and that comes back really to the testing as well. You'll need to test for those, and you might even run into bugs too on platforms. The software, when you're doing cross-platform development, you're targeting multiple different operating systems, and they all have their own frequency of updates. And that means occasionally they introduce bugs, but they also fix bugs too in those updates. And so that's a consideration as well. And there's also the development costs. So some of the cross-platform development technologies are free. The underlying technology might be free, but then there may be SDKs, software developer kits from vendors where there is a cost to do that development. So when looking at the different cross-platform options, cost may be a consideration as well. Okay, so at this point, you've decided to build a native application, you've decided to go cross-platform. Now we're getting into some of the other considerations. So how do you choose a cross-platform SDK? Well, essentially you have to think about the business, technical, and user requirements of the application that you're building. What devices do you need to support? What platforms, what operating systems do you need to support? How is the application going to be deployed? Is it going to be deployed to public app stores, or is it an internal business store, or is it going to be sideloaded onto the device? What skills do you and your team have? Are you going to be able to build a team that has the skills required for that technology that you've picked, or do you already have those skills? And that's an important consideration as well. So there are multiple options available for cross-platform development. Oracle and Java. There's the Qt company, and there's also Microsoft with Xamarin. And we'll take a look at each of those options and the ArcGIS Runtime SDK that targets each of those technologies as we go through. So the ArcGIS Runtime, we actually build it to be cross-platform. So we have a C++ code base that we talk about as the ArcGIS Runtime core. And we compile that for multiple different architectures and platforms, 32-bit, 64-bit, ARM32, ARM64, and also the different rendering technologies that those platforms use. Currently, that's typically OpenGL and DirectX. There are obviously newer rendering technologies that we're looking at, Metal on iOS, Vulkan on Android, and newer versions of DirectX as well. But we build the ArcGIS Runtime to be cross-platform, and we're compiling it for Android, Linux, iOS, macOS, Windows, and Windows 10 UWP apps. And really the thing to emphasize about that is that means the functionality that's implemented in the ArcGIS Runtime is available to you whichever SDK you choose. You get the same functionality. So the ability to render a map or call into a routing service to generate a route between two locations, that's available in all of the ArcGIS Runtime SDKs consistently with a consistent API design pattern as well, whichever SDK you choose. We then expose that ArcGIS Runtime capability to you in Android, Java, iOS, macOS, Qt, and .NET. So those are the SDKs that are available to you as developers that have the public API that you develop against to build your applications. And there are three that have that provide cross-platform options: Java, Qt, and .NET. And those are the SDKs that we'll take a look at in this session. Okay. So now I'd like to hand over to Tyler, who'll take us through the ArcGIS Runtime SDK for Java.
Cool. All right. Thanks, Mike. As we said before, my name is Tyler Sheeby, and I'm a product engineer on the Java SDK. Before I get started, I just wanted to see a show of hands if any of you have used Java already building apps. Okay, great. So I have some of you to win over. That'll be great. So as far as cross-platform Java development goes, Java was actually created for this very purpose, to be deployed anywhere. Sun Microsystems actually coined the phrase write once, run anywhere. So it's baked into the language for sure. And they do this using the Java Virtual Machine, or JVM, which basically abstracts away the programs you're writing from having to access individual APIs of all the different operating systems. Instead, you can compile down to bytecode, run on the JVM, and the JVM helps call into those specific operating system APIs. Now, that said, that Java can target pretty much any platform. The ArcGIS Runtime SDK for Java only targets desktop platforms, including Windows, Mac, and Linux. So unfortunately, that means that it is not directed to web apps, backend server solutions, or mobile solutions. That being said, usually the ArcGIS platform as a whole has a solution for these cases. Even within the runtime, we have the ArcGIS Runtime SDK for Android as well, in which you can also use Java to provide a mobile solution. And I'll talk about that in a little more detail later. Another consideration for Java is it's not a pure Java library. As Mike was talking about, all of the runtime SDKs run on top of a C++ core. And for Java, that means we're accessing that through the Java native interface. In terms of UI development, there's been a few different options in Java for the last 10 or so years. Many of you might be familiar with Swing. The new standard is JavaFX, and a lot of our components are built on top of JavaFX. And I'll be talking about that a little bit more later in the presentation. And the last and kind of major consideration of when you're looking at using Java is the massive ecosystem of mature open source libraries that are available to use. Since Java has been around for a very long time, you'll have no problem finding a library that often meets whatever needs you have. And if you're using the Java Runtime SDK for Java, you're going to be able to use those as well. And also that means you have a few different options of free, really powerful IDEs. And of course, the Jerry is free to use and deploy as well. So there's not as significant of a buy-in when you start developing with Java. And the last point I'll make about Java is even if you're not a huge fan of that language, you can pick another JVM language as long as it's fully interoperable with Java. That should work with our SDK. We don't explicitly recommend doing that, but languages like Clojure or Scala or Kotlin, which is becoming very popular, are also options for you to consider. So real quick recap of the API architecture. Like I said before, everything's running on top of a C++ core. There's that small interop layer where we're using the Java native interface to call in and do rendering from that Java API. And the main point in this slide is that the Java APIs for Java SE and Android actually share a common code base. And this is pretty significant because it's at least 90% of our code is in that common API area. So that actually opens up the possibility where you could have an app that uses the non-platform specific APIs in the kind of core module, which can actually, where you can put like your business logic and then perhaps use that in both an Android app and a Java SE app. And while we don't explicitly recommend that you do that, it is an option. Now, in the top sections where it gets platform specific, those type of things are like platform UI, environment settings, those kind of things. So things to consider. If you're targeting desktop applications and then you want a mobile solution and you're very comfortable with Java, Android should be very easy for you to get started with, because the API is pretty much the same. Now for Java SE, as I was saying before, the layout of your app, how you're actually going to design it, is through JavaFX. Basically, at the start of any application, you're going to get a native window called a stage from the operating system. So you can see that the same app in the screenshot, the window will be styled correctly for the operating system, including Mac and Windows in this case. If you're actually coming from a background of web development, you might actually like using JavaFX because styling is done with CSS, and there's also an option to use fxml, which is an XML markup language, which is somewhat similar to HTML, I guess, except it's actually statically typed, and you'll have compile time warnings. And so that is a very powerful mechanism for also creating model view controller type apps. Now, in many cases, you won't have to worry about the underlying operating system. Usually, that app, you write the code once, and it's going to run on all of those, and you don't have to make any platform considerations. One thing that I will mention that's a common gotcha is file paths. So Java will help you abstract and run on all these operating systems, but you still have to kind of know what you're dealing with when you want to access files or things like that. Moving on to distribution, what it's actually going to look like in terms of deploying these apps. Of course, you're going to use your IDE of choice, and you have a lot of options with Java that have been around for a long time and will continue to do that. And you're going to create your application, and it's going to basically come out to a single jar file, an executable jar. And when you deploy that, the important thing that distinguishes Java between the other solutions that you hear about is that single compiled file is the thing that you run on all those platforms. You're not compiling to each platform in a different way. So on Windows, Linux, and Mac, you're going to see that same jar file, and then you're going to have the native libraries that are in that C++ core, depending on the operating system. Now I want to talk about kind of a demo showing what that distribution looks like. And this app runs on Windows, Linux, Mac. I'm just going to show it on Windows this time. But it's really to show how that is distributed. And in this case, we're doing probably the simplest option, which is just to distribute as a zip with that jar and those native libraries. But it's actually fairly easy if you want to include a JRE or make a fully executable app based on the operating system. And the little snippet at the bottom is a command that will allow you to do that. So we don't do that for our own deployment on the sample viewer, which I'm going to show, but that is an option for you. So I'll exit out of this real quick. And so this is actually the unzip. Let's see.
Might be extending displays.
Okay. Try to get that. All right, sorry for the delay. So this is the unzip sample viewer that we distribute, which actually, just as a pitch for that, we'll show all of our samples that we distribute to show you how to use the SDK, which is about over 100. So I highly recommend looking into this. But the contents are very simple. We have that single jar file, which is an executable jar, which means I can just double click it and run it, which I'll do shortly. We have some local data as well, and then we just have the native libraries in these JNI libs and resources folders. And I want to dig into these a little bit to show you some options on how you can actually target specific desktop platforms if you wish, or minimize the size of your distribution. if I look in JNI libs, you'll see a few folders in here, mainly named with the operating system in mind, and then a DirectX folder. So let's say that you're building this desktop application with Java, and you're not really targeting Windows at all. You just target Linux and Mac. You can actually just get rid of these files, or these whole folders. DirectX is only shaders for Windows, and Win32 and Win64 contain the DLLs that you'd need for Windows. So you can significantly reduce the size of your distribution if you want. That said, if you want an app, I mean, there's really no reason not to allow your app to be used on all those different operating systems. You're not going to have a performance penalty in your app. It's just going to increase the size of your distribution. Last thing is resources. This is kind of local data that's used for different things, hydrography, for kind of nautical charts and things like that. Symbols are more like special military symbology. If you don't have uses for that, you can just remove it. It's no big deal. But again, keeping all those things, no performance penalty, just might increase the size of your app. Lastly, I just want to double click this to show that it works, and to also show how you get kind of the native window that acts just like a normal Windows window, and then you have the icon and everything. And you could also make this an executable app installed to your machine, just like any other app. All right, so that's the sample viewer. Jump back into presentation real quick, just to summarize. Okay. So just in summary, the IDE and the JDK, which you're going to use to develop apps, are free. Very easy to get started and deploy that way. Deployments, again, this is the main distinction between the other solutions you'll hear about. That deployment can be identical. That same unzipped sample viewer that I showed, throw it on any desktop operating system, it's going to work without any special considerations. And then JavaFX is a very powerful tool and nice for even JavaScript developers, which styles appropriately for the platform that it's running on. Some of the cons, the client must have Java installed. This is usually not something to worry about because most people have Java installed on their machine at some point. And then, again, we don't target mobile or web apps, but there are alternative solutions. Here I'm showing the Android SDK. And Gluon can also be used to take JavaFX desktop-based apps and port them to mobile. It's a third party. We don't explicitly recommend it, but it is an option for you. And then those other JVM languages are also an option for you if you're not sold on Java. So that's all. I'll turn it over to Michael Toombs.
All right. Thanks, Tyler. So I'm going to talk about what you need to know if you about Qt and QML for the ArcGIS Runtime SDKs, some of the quirks, some of just the getting started things that you need to know about Qt in general. So starting with some background on the Qt company itself. The Qt company has been in business for a while. They've been developing cross-platform framework for about 25 years. It's really all they do is build cross-platforms framework for C++ and a language called QML. And they're really trying to build these sort of ready-made, abstracted APIs for you. So you really have to just code once and then take that code and compile it on all the different platforms. The Qt company has a large open source community, which is really, really nice. Obviously, they've got a lot of folks that work at the Qt company themselves and contribute to their framework. But you could typically get at that code, clone it, make fixes to it, customize it to what you need to do. Because it's an open source community, it's really beneficial for bug fixes and new features, because there's quite a lot of partners that are working with the Qt framework as well. As far as platform support, Qt's going to get you Windows, Linux, macOS, Android, and iOS for the different chipsets that are available on those platforms. And again, that's taking the code and compiling it and running it on those different platforms, literally the same code. Something that's up in the air, and I'd like to hear feedback from you, is Universal Windows Platform. We've done some testing with supporting this framework, the UWP framework, and it works well, but we're looking to hear if there's demand for this platform for using Qt, because supporting just another platform means more testing for us, and we'd like to kind of just know if you're interested in that platform. Obviously, the Qt company supports most platforms when they're starting to come out. The other one we've been dabbling with is Linux embedded ARM. So these are embedded devices that are ARM 32-bit or 64-bit embedded cards, and we actually have on display something that's running on a Linux embedded system on the island if you wanted to take a look. But curious to know if anybody's deploying to these types of hardware, because this is a big user base for the Qt company, actually, is the Linux embedded ARM systems. So with the ArcGIS Runtime SDK for Qt, we have one SDK, but we actually have two different APIs that you can use. And you can't combine them and use them interoperability, but you can use them separately to build apps. The first one is C++. And in the Qt community, this is typically the way that you would build apps. Is you would have your C++ business logic, and then you'd pick one of the UI frameworks, which is the first bullet point there. There's either the Qt Widgets framework, which is mainly to target the desktop platforms, Mac, Linux, Windows, or you can pick the newer Qt Quick UI framework. This is usually the one that we recommend. It can target all of the platforms. It's the Qt company's UI framework choice moving forward. If you're just getting started, Qt Quick QML for your UI is really the way to go. With the C++, you get the modern C++ 11, 14 type language support. You can actually have, C++ libraries that you can hook right into Qt and bring in third-party libraries, or if you have standard C++ libraries, you can integrate those nicely into your Qt apps. And you get really fast performance, really like all the runtime SDKs, you get really quick performance because most of that's being done in the runtime core. The C++ API binds directly onto that C++ core. The QML API is the second API. This is the API running in App Studio. If you're using App Studio and using their framework, they're consuming this QML API that we have from the ArcGIS Runtime SDK for Qt. You're going to use Qt Quick for the UI, sort of like C++, but now you're using Qt Quick for the UI extensively. You can't use widgets in this environment. It's a declarative language. I'll give you a little code snippet of what that looks like. And that's how you declare your components and use those components. It's really familiar to web developers. And then when you're coding up your business logic, or you're handling events, you're actually doing that in JavaScript code. So I hear a lot of feedback from some of the web developers that are deciding to go native, where they've been able to jump onto the QML API pretty quickly and get up to speed pretty quickly because of it having this JavaScript feel. And that's mainly because it runs this JavaScript engine natively, not in the web, but natively on the platform within the Qt framework. Actually runs that on the device. I mentioned App Studio, and Survey 123 and a release coming soon is going to start integrating in this QML API as well. So if you wanted to extend Survey 123, you can get at the runtime QML API in a future release. So here's an example, because I get a lot of questions about what does the QML code look like, and this is kind of just a snippet. You can kind of look at this and see what it's doing, because it's really highly readable. You get this JSON CSS-like syntax where you're declaring these components, like this button, and you can anchor it accordingly. This one's anchoring to the top left of its parent. And then when you're in events, like say for instance here's in the on-clicked event for this button, you're writing imperative JavaScript code to handle events. And we have within the QML API a way to instantiate objects in the imperative code and create those and be programming in JavaScript in that environment. Dynamic property binding is really, really powerful. So if you want to change the state of one of your UI controls, you can bind that to a property simply by just having an expression typed out. So this one, for instance, is when the map's load status is equal to load status loaded. Whenever that evaluates to true, then that button's going to become enabled. If it evaluates to false, it'll be disabled. So that's one way to have nice one-liner property binding code. And then there's the ArcGIS Runtime, which we seamlessly integrate into the QML framework provided by the Qt company. So with the Qt SDK, there's some setup involved. Much like a lot of our runtime SDKs, you have to get your compiler downloaded and get different SDK dependencies installed. That means for Qt, you've got to do quite a bit of work if you wanted to target all of the platforms. So like iOS, you'd have to make sure you get your Xcode compiler. Windows, you have to have your Visual Studio compiler. That can be the Visual Studio Community Edition. Get some of the Windows SDK debugging tools installed so you can have the debugger available to you. Linux will be GCC, and then Android, you'll have to get the NDK and the SDK, or you can install Android Studio, and I'll show you in a little bit how you can hook up those bits into the Qt Creator IDE from the Qt company so that you can get rolling with your development. But there is a little bit of a setup involved, and we document that real clearly on our website. Developers.arcgis.com, our website. But once you get set up, you're usually ready to roll, and you can start building your one app or multiple apps, and you can do that using the same code, which is really, really nice. I mentioned the Qt Creator IDE. This is really the IDE of choice if you are targeting multiple platforms. If you were just targeting Windows, you could use the Visual Studio plugin from Qt to use the Visual Studio IDE, but I usually recommend Qt Creator if you're going back and forth between, say, Windows to develop your Windows app, and then Mac if you want to develop on, iOS or Mac. You get the same experience with this IDE because it compiles and runs on all those platforms. Plus, you can develop and test directly from this IDE, and I'll show you an example of that in a little bit. And you can also deploy from this tool and start working with your apps directly from that tool. So I'm going to drop out of the slides and pop into Qt Creator. There we go. So Qt Creator, here's what the IDE looks like. Just sort of blow up that code a little bit. So how do we get started to integrate Android? Let me give you an example. So I go into the Preferences, Devices. Here's this Android tab. And this is where, once you've installed the JDK, the Android SDK, and the Android NDK, you just simply give the paths to Qt Creator. It doesn't automatically detect where those are when you install those bits, but once you get the paths to where those are located, you just copy and paste them in here. That tells the IDE where to go get the NDK and the SDK and the JDK. And then once you do that, you're pretty much ready to roll with Android. I'm going to run real fast an application. And typically, once you have your project opened up, here I have our DSA example app project. I'm going to hit the play button, and this will typically run the compilation and then actually pop up your app, and you're working with your application directly. This is running on Mac OS, and this is our DSA example app, which released earlier this year. Let me close that down. Now, if I wanted to say that was great for Mac, but I want to test for Android, over on the left-hand side here, I just have to hit this little computer button over here and switch this, say, to Android, and I'll change this to a Android phone, and that'll make sure the back-end make files are all hooked up and being generated properly for Android. And then we just have to hit the play button, and here it's detected that I have my Android Samsung Galaxy phone hooked in to the computer. I hit OK, and this will start running the actual compilation here and start deploying to my Android phone. And the same thing with iOS. I could just choose iOS here, release, say which phone I want to run the application on, and hit play, and we can start deploying to iOS. So if you can switch to 3. Here's the application running on iOS. And this is the same code that I just showed you running the application on Mac OS, but this is running on iOS. It has a little bit of a different UI spin, which you might notice. I've got the menu on the bottom of the application instead of it being on the left-hand side. It can run in landscape mode as well. But it's got a little bit of a different UI, and one of the things that is different as well is, say, if I want to come in here and view my talk, I actually get sort of a full screen takeover for the overlays. And if I press on this menu button on the right-hand side, I get this menu to pop up from the bottom, and you can actually say, okay, I want to zoom to this layer, and it'll pop back in and zoom to the layer. But the UI has a certain look and feel that I've customized specifically for the handheld mobile device. And then back on, let's flip back over and show you, I think it's 5, the desktop again. And I'll show you on Mac what is different. So notice here's our sidebar over on the left-hand side. And if I look at the overlays now, it's this slide-out menu coming out from the side. So a little bit different UI experience. And if I click on this menu now, it's just a pop-up menu in place from where my menu exists. So this is traditionally takes a little bit of work to do this with Qt, because typically when you build a UI with QML, it's going to look and feel the same on all the platforms. So I'm going to show you kind of how you can do this so you can get a little bit of a different UI experience. So dropping back into the IDE, this is the image that we have, which are those little ellipses for the menu. And I put a mouse area over that menu. And when it's clicked, I have some logic in here that checks if it's mobile. So I've defined this variable is mobile. And if I've detected I'm running the handheld version of the app, that's going to be set to true. If I've detected I'm running the vehicle version of the app, it'll be false. So it sort of has some conditionalization here to choose which menu we want to open. So here's the vehicle menu that we open, and I've defined that as a certain menu component. Else, we go in and we choose the mobile menu. So the mobile menus is kind of down here at this point, which it has it's different code. So I've talked about it's the same code on all the platforms, which is true, but you may have to write specific code if you want a different experience between mobile and the desktop platform. You can do such things such as load in QML files for the different code if you didn't want to have this compiled all into your app, which is probably what I would recommend and probably should have been something we've done in this code, so that when you're compiling for the handheld app, you don't bring along this additional code that doesn't really apply to the handheld app per se. So that is another thing that you can do with the loader component in QML. All right, so that's that. Let me head back into the slides here. I'll try to zip through this because I know we're running out of time. So there's Qt Quick Controls. There's a version 1 of the controls, and those are going to get you the native look and feel of the platform. So here we have a little screenshot running on Mac OS and Android, and you can see they sort of look like native Mac OS and Android. That's kind of a little bit of an older screenshot of Android, but you kind of get the idea. And then there's Qt Quick Controls 2. And they have a few different styles that you can choose from. There's a default style, and then there's a material style, which is based on Google's guidelines, and there's a universal style that's based on Microsoft's guidelines, and there's a few more. There's a fusion style, which is sort of this older style desktop look, and this imagine style, which is based on image assets. Qt Quick Controls 2 is the new UI control framework of choice by the Qt company. But what it does is it makes the controls look exactly the same no matter what platform you're deploying to. You're not going to get a native look and feel. So keep that in mind. All the controls will look the same if you're using it with Qt Quick Controls 2. So just to show you a really quick example of Qt Quick Controls 2, if we launch back into Mac, you'll see I have sort of this material design look and feel. This kind of looks like a Windows styled app, and that's just how we decided to lay out the different UI. But you can see here, this isn't really kind of traditionally what a Mac UI would look like. We've chose to style this with Qt Quick Controls 2 using the material style, so you can kind of get a nice look and feel, and you can color it and you can theme it accordingly. So one way in which we do that is the Qt Quick Controls 2 conf file. And here's where you can actually come in here and play with, define and play with different colors. So here's my primary color. It's kind of set to this darkish gray. I'm going to change it to this purplish color and show you how you can actually modify the UI from using the configuration file. So now you can see when I launch the app, it's got almost a different kind of theme color scheme on it for that primary color. So that's really powerful. Use that to your advantage when you're using Qt Quick Controls 2. That configuration file can be kind of handy. And then to kind of finish up here, there's QML limitations, some of these cross-platform hurdles. The QML API is an abstracted API from the Qt company. In doing that, sometimes if there's different platform nuances between, say, the Android SDK or the iPhone SDK, say, for instance, for push notifications, sometimes the Qt company hasn't come in and abstracted those out and have those available in the Qt framework. Push notifications is a big one that we continue to get asked about that the Qt company does not have an API for. So if you need push notification support on the client side, you have to code that up yourself. Access to the Android photo gallery, inter-app communications API, those are things that aren't available. QML is designed for UI, so in the C++ APIs, network file I/O, a lot of those text-to-speech, some of these APIs aren't exactly bubbled up to the QML framework. You can use our ArcGIS Extras plugin library to get at some of these that we provide, and we've wrapped those up for you. Or App Studio does a really great job with their framework to wrap up some of those capabilities as well. And then you're going to have UI limitations. I've talked a lot about the native look and feel and what you're going to get with Qt Quick Controls 1 versus Qt Quick Controls 2. Licensing, there's two different license models. The one that you're going to use if you're targeting all the platforms I've talked about today, the application development license model. There is a commercial offering, and then there's an open source offering, and you just have to kind of go in there and read what the two different ones offer and choose the one that best applies to you. More information you can get from the Qt company website there at qt.io/download. So to finish up real fast here, pros, a lot of the stuff I already talked about, same modules, you get the same look and feel. It's native, so you get access to all the sensors, a lot of stuff Mike already referred to, a nice open source community. But some of the cons, sometimes you have some of these incomplete native APIs because of the common abstraction that the Qt company tries to obtain. For instance, I mentioned the push notification support. Look and feel of the native platform, oftentimes you're not going to get that, especially if you're using the new controls. And then the Qt framework is an additional framework, so it may increase your app size. It has additional libraries it's got to pull in to support Qt. So that's it for me. Over to Mike.
All right, so we've taken a look at Java and the Qt technology as well. Both good cross-platform options. Now let's take a look at .NET and Xamarin. Okay, so this, I've got a few slides and then also a demonstration. It follows the same pattern that you've seen in Java and Qt as well. I'll talk about the technology itself and then talk about how the ArcGIS Runtime SDK for .NET interacts with that technology, and then we'll take a look at a demonstration of the IDE and the tooling. So Xamarin is a cross-platform development technology for .NET. Okay, .NET is over the last few years has expanded across multiple platforms, so it's available on Windows, Android, iOS, macOS, Linux, Tizen, and Xamarin enables development with .NET and C# for those platforms. With the ArcGIS Runtime SDK for .NET, we're actually targeting Android and iOS specifically with Xamarin. We could, as Michael mentioned in the Qt presentation as well, we could add support for other platforms, but and we'll take feedback on that from you if that's something you're interested in. But at the moment, we don't have any plans to go beyond Android and iOS with Xamarin. Xamarin uses the Mono .NET framework, so it's a cross-platform implementation of the .NET framework. And it effectively compiles into a native Android or iOS application, or native applications on the other platforms that Xamarin supports. So that means you're programming against the Xamarin API, but ultimately the application that you get is a native Android or iOS application. Xamarin exposes all of the APIs in the Android and iOS SDKs. And the Xamarin team is very good at developing this in advance of those, working with the betas in advance of Android and iOS updates. And so pretty much the same day that an iOS update or an Android update becomes available, the Xamarin API is released at the same time, providing access to those APIs. The really great benefit of Xamarin and .NET is that it allows you to reuse almost all of your .NET code across Android, iOS, and Windows. So the code that you're writing in C# using .NET types is able to run across Android, iOS, and Windows. You then will need to think about UI code that is platform specific. So you'll have projects that target specific platforms, and you'll need to think about the UI specifics on those. You'll also find that the device code that you need to write, for example, for connecting to Bluetooth, maybe for using GPS or other sensors on the device, that might be platform specific as well in some cases, because they're just simply different APIs and different patterns on different platforms. In that sense, actually, Xamarin has a preview of a library called Xamarin Essentials. There's a GitHub repo and there's a NuGet package. And that's an effort from Xamarin to actually provide a cross-platform API onto a lot of those things that you want to do. For example, accessing sensors and that kind of thing. So I'd encourage you to take a look at that. And then I talked about how with Xamarin, you need to write UI-specific code. There's a library called Xamarin Forms, and that actually provides cross-platform UI support. So it's a cross-platform UI framework. Ultimately, the UI is still rendered into native controls on the target platform, iOS, Android, and Windows. So you don't lose anything in that sense from using that, but you're not able to make the UI quite as specific as if you were building specific Android, iOS, or Windows applications. One of the nice things in Xamarin Forms is that you can actually use XAML or C# to create the UI. And as of the latest release of Xamarin Forms 3.0, you can use a combination of Xamarin native UI and also the Xamarin Forms. So you might choose to build a native UI for Android, iOS, and Windows using Xamarin for the main UI within the application, and then you might use Xamarin Forms to speed up your development for specific parts of the application where you need to show a form or a page for a data capture or something like that. There are also lots of other abstraction libraries that can reduce the amount of platform-specific code that you need to write. And you can take a look on nougat.org to find those. Okay, so what's the ArcGIS Runtime SDK for .NET, and how does that relate to Xamarin? Well, the .NET SDK supports Windows Presentation Foundation, WPF, development. It supports development for Universal Windows Platform apps, or UWP, and then also the Xamarin Android, Xamarin iOS, and also Xamarin Forms on Android, iOS, and UWP. So it supports all of those options. And what that means is it enables you to write the same business logic using the ArcGIS Runtime SDK for .NET, using C#, and run that across Android, iOS, and Windows, using either the native UI framework for Xamarin or using Xamarin Forms to actually share a lot of the UI logic as well. So let's take a look at the architecture of the .NET SDK then. Down at the bottom, you've got the different operating systems, so they obviously have different platforms, different technologies in there. That orange band in the middle is the ArcGIS Runtime C++ core. That's where all of the ArcGIS Runtime functionality is implemented across those different platforms. And then there is a bit of interop code, and we have the .NET C# code that we write that exposes the API to you as developers. That uses different .NET technologies, different .NET implementations on each platform. So the .NET Framework for WPF, .NET Core for UWP, and then the Mono .NET Framework for iOS and Android. But actually with .NET Standard 2.0, which we now support as of the latest release, 100.3, that .NET Standard supports means we can rely on the same set of .NET APIs on each of those platforms to provide that functionality. And then you write your UI in WPF, UWP, iOS or Android projects using either the .NET WPF API or UWP API, or it could be Xamarin Forms as well for a common API. So let's take a quick look at how you would architect your project then. You will have an Android application, an iOS application, UWP application, WPF application. Those are your projects, then your solution. And then you have another project that contains your shared code. And finally, that's a shared UI code if it's using Xamarin Forms. And then finally, another project with your shared code for all of the business logic. So let's take a look at that within Visual Studio then. So the scenario here is it's a campus locator application. And what I want to show is that if we take a look up here within our project, we've got a platforms folder, and that contains application-specific projects for Android, iOS, and UWP. And in each of those, there's a specific UI implementation, but it's using all of the code that is actually in this business logic folder up here within our core project, and that compiles into a DLL that's referenced from the other projects. And then there's actually a forms folder here as well, and the really nice thing about the forms technology there is that we've got another shared project, the forms project, and that has the UI for all of those other application projects, the Android, the iOS, and the UWP, all they simply do is show the UI within that Forms project. So it's sharing all of the UI logic across those three platforms. Okay, so there are some pros and cons to using Xamarin. Xamarin, the technology is free and open source, but the tooling, Visual Studio, is not necessarily free for most commercial development, and you can check out the Visual Studio licensing to understand more about that. The great thing is you can target all of those platforms within a single IDE within Visual Studio and on a single operating system, at least for your development. If you're doing iOS development, you will need a Mac. You have full access to all the native platform APIs. Some of the cons, there's not 100% abstraction of all the platform code, and that's where I talked about you might have to write some platform-specific code for handling different, perhaps Bluetooth or device sensors. It's a significant technology stack, and that's actually true with the other cross-platform technologies as well. When you're building for all of these different platforms, if you're building for iOS, then and using Xamarin, you've got Windows, Visual Studio, probably, and then you've got you need a Mac, and you've got Xcode running on there as well. And just having multiple operating systems, multiple IDE components from different vendors, and keeping all of those in sync can be a challenge. So that it shouldn't be underestimated, but it does provide excellent benefits. Right. So the ArcGIS Runtime then is cross-platform and provides 3 cross-platform SDKs, Java, Qt, and .NET, and that's what we've heard about today. So those are the 3 SDKs. How do you choose which one? It's really about understanding the expectations of your users and the types of workflows and types of scenarios that you need to support for your users. All right. Unfortunately, we are out of time for questions, but once my colleagues and I have packed up, we'll be available just outside the room there to take any questions that you might have, and we'll be available in the showcase until midday. All right, thank you very much.